Okay, okay, but in my stats one, they only given quiz one, not in all other.
That's unfortunate, but I think they do give it in start. So, I mean, at least they used to give it in during my time. And now I don't know what they do.
Okay, okay.
Okay. Yeah, Vardhan, good to go. Lata, where is she?
Hello, hello.
Introduce and then Vardhan is good to go then.
Okay. Hello, everyone. As we all know, we are here for the session for revision of Stats 2 for Quiz 1, which will clear up all your concepts for the Quiz 1. And here we have Vardhan, who has also been guiding and helping us with Python through the Python Odyssey series. You can check out the playlist on our Sundarban's House YouTube channel. The link has been pasted in the chat box. So, yeah, without any delay, let's begin the session. Over to you, Vardhan.
Yes, thank you, Lata. So let me start sharing the screen first. So I will tell you the plan for today. So first we are going to go over the topics and the concepts we have done, but not in very much detail. It would mostly be like an overview. So if you have done it, then would be great. If you have not, I can discuss some few topics, not all of them, in some more detail, but it would be mostly like a revision. Can you guys see my screen?
Yes.
Yeah, it's visible.
It's visible. Just give me a second. Okay, this color is not there. Yes. Right, so before we even start like stats 2, there is something known as week 0, if you remember. So in week 0 we just revised the concepts which are relevant for stats 2 from stats 1. So these concepts were in stats 1 already, basics of probability. So we talked about experiments, outcome, right? So whatever the set of the outcome is, we call that sample space, which is denoted by omega or s. So in actual in the theoretical text, it's denoted by capital omega, and event is any subset of that omega, right? And how do we define probability? Probability is defined on the some subsets of that omega, some subsets of the sample space, which are also known as events, and it is mapped to some number, some real number between 0 and 1. Right, so let me just mark it as well. The things which are slightly more important, the probability is just mapping from the set of events, set of possible events, not all events, and all events or all subsets are not possible. So some set of events to 0 comma 1 close interval, right? And there's some properties which I think should be fine with you by now. So empty set has 0 probability, full set has, the full omega has 1, and if you're taking union of disjoint sets, so their probability just breaks down into summation. And then you have the complement property and the normal inclusion exclusion principle for the two cases when A union B and A intersection B is given, right? So this is the very basic. So one thing, so one of the most important concept within stats 2 is conditional probability and independence, right? And you will see it again and again in continuous setting, discrete setting, right? So whenever for a given event B, so here A and B are events. I have not mentioned that A and B are events. That means subsets of the omega. So whenever there is an event which has some non-zero probability, then I can define probability on some other event given that non-zero probability event, right? So it is just defined as probability A given B is just equal to probability that both of them happens together divided by the probability of that non-zero event, which is B. So you just need to remember I divide by the probability of the event which is given after this line, right? So you just need to remember. So B was after that line, that's why I divide by B. You will get confused in those kind of things also. This somehow divide by the first event, and it is independent if the numerator. Yes, Yogesh. Sure.
Actually, every lectures on YouTube are in English. So, Arif, will you explain it in Hindi sometimes? Like the English lectures are a bit hard to understand
I'm not very sure because I
for
think
me.
somebody was asking about English or Hindi. Uh, Lata, are you there?
Yeah, hello.
Yeah. Should I continue English or Hindi? Like I don't know.
In whichever you are comfortable, you can
I'm
continue.
comfortable in both.
Like
I don't mind.
in between, while teaching core concepts, you can like teach it in Hindi, like so it would be like clearly understandable by others.
Ask if all are comfortable in Hindi. I am
Yeah.
Yes.
comfortable.
Okay. Let's
Make a
not.
vote for that.
Okay, I don't think there's a poll option, and let's not waste time in this for now. So I will try to explain things in Hindi if needed, right? So yeah, because we have
Yes.
time constraint, right? So probability that both of the events happen, so दोनों events होने की probability क्या है, you just multiply with the probability that you just multiply with the probability of the separate two events. So यहाँ पे क्या किया मैंने, so probability that A and B दोनों होंगे, I have just multiplied the individual probability. These are individual probabilities, right? So it's just P of A times P of B, right? And there are two of these theorems which I usually don't talk about because these are like somewhat very trivial. So it's obvious होते हैं ज़्यादातर, इसमें there's nothing complicated. So probability that A will happen can be just broken down into two events, B and B complement, with this formula, right? So this directly comes from the definition of conditional probability. There's nothing complicated about it. And and Bayes theorem says, Bayes theorem helps you. So through Bayes theorem आप क्या कर सकते हैं, probability that B given A can be written in terms of probability A given B. There's some kind of conversion using that, right? It's just some kind of conversion. That's all. So that was the basic from stats 1. Now we have come to actual quantitative stats 2. So it starts with random variables, but we have done random variables in stats 1 also. If you don't remember, I will just define in a more mathematical way. So random variable is just it's a function है that is from the set of omega, which is from the set omega, which is a set of sample space, all the possible चीजें जो possible हो सकती है from real to real numbers, right? So it takes some values on the real line, and it is discrete. This people always forget. It's discrete if and only if the range is at most countable, so it can be countable or finite. So range is denoted by tx. So for a given random variable, अगर कोई random variable है, so through that random variable, I also define a function known as probability mass function, which is denoted by f of x, and it is just the value from each point in its range to 0, 1. So it just tells you the probability that वो point attain होगा. That's all, right? And similarly, I have joint PMF, which is for two random variables. It is just the probability that these 2 points are attained. So f capital X y at small x comma y is just probability that capital X takes the small value x and capital Y takes the small value y. Yes, Rishabh, I will share the notes. Yes, I will. I don't know how to share it, but I will tell it to the operational team, so they will deal with it, right? Yes, so that is joint PMF. Joint means you're joining or you're combining more than one random variable. So it's just a basic English in the sense joint. And marginal means you talk about margins, right? So if this is the joint distribution given, so usually we denote it using table or a matrix. So marginal is just you take you fix one variable and one of its value, and you just find the probability over that area, right? So if you fix for x with respect to y, small x, then probability that it will take that value, the capital X will take small x. It just you sum up over all the possible values of y, fixing that x, fixing that x. So here this x is fixed. That's why I've written explicitly also. People forget that. So right. So whatever thing is given on the left hand side, this x is given on the left hand side. I just fix it on the right hand side. That's all. Now again, as you can see, conditional distribution and independence are coming again. This will come back again and again, and it is very useful. So conditional distribution given a event, given an event, right? So this is an event. A is an event. Again, you just use the basic formula which we have seen. So here we had two events, right? So I just write probability A and B divided by probability of B is just probability A given B. So here also, instead of substituting the first event, you just write the event as x is equal to t at a given value t, right? So I think I have made a mistake here. This should be t, not x. So f of x at t given A, an event, is just probability that x will take the value t, it can attain that value, and A can happen divided by probability attain. As I told, anything after that line comes in the denominator, right? And similarly for a random variable, it is just defined using the joint distribution. And independence, I think it's much more, it's easier to see after looking at the previous definition. So independence of two random variables is defined through its joint probability mass function. So if joint probability mass function also breaks down like the event thing, so probability that probability of x comma y taking value x comma small y is just equal to the probability that they take this individual value, right? So these are the individual values, individual values, individual. See, it is exactly this. It is exactly same as the event case where we just talk about the individual probabilities, right? And then we have the definition of IIDs, which is not very hard to see. It is that if I have some set of random variables x1 to xn, they are independent to each other pairwise, and they have the same probability mass function. When you just talk about x1 or x2, they have the same probability mass function. That's all. That's the case. And functions of RV, we will see this in through examples. So I'm not explaining here. Yes. So I will just talk about this CDF, which is cumulative distributive function. Cumulative, it just adds up everything. So if you are at given x, it tells you what is the probability that anything which is less than equal to x has happened, right? So that is the formula, probability that x, capital X, has taken some value less than equal to x. So for a small x, it will tell you what is the probability that anything has happened which is smaller than me. That's all. So before this, let me talk about continuous random variables. So continuous random variables is just a setting where the cumulative distributive function becomes continuous. But in discrete setting, it is not continuous, right? So right now we don't have that much of time so that I can give you intuition and all, because this is a revision session, right? So I'm just telling you as a fact that for continuous setting, the CDF is continuous at all x. I have written a definition as well. Capital F denotes the CDF. It is continuous at all x, and probability of attaining a given point is 0. Probability of attaining a given point is 0, right? But for the discrete setting, you just find the difference. This is for the discrete setting. Discrete setting, right? That's all. And everything follows except this. There is a new terminology known as probability density function, right? So probability density function is a function. If you integrate that, you will get the cumulative function, right? So integrating probability density function gives you cumulative distribution function, right? That's all. So that is the idea. And we will I have picked up some question which will tackle all these kind of examples, so it would be clear. Now we will talk about how to analyze RVs. This is the last topic for week 1 to 4, but this is done in week 3, but I did it at the last. So we talk about expectation, which is also known as mean, right? So we have only talked about the discrete setting. We will see the continuous setting in yes, somebody has a doubt.
Can you repeat that CDF and PDF's relation of that integration, please? Again?
Yes, yes, sure. By the way, if you want to ask doubts, you can ask in Hindi as well. I can understand that, right? Right. So PDF is just a function. If you integrate that function, you will get the CDF. That's all. So that is the property. And usually it's given to you. You don't need to differentiate and find it, right? So in most of the questions, it's always given. Yes. So let me move forward. So I will take 2-3 more minutes. Then I will come back to PYQs. The expectation for the discrete setting, right? So remember, this is a discrete setting. You will see the continuous setting in later weeks. In discrete setting, it is just the summation of the product of the point times the probability that that point is attained, right? So all these x are in its range, right? So that you need to see. That's all. And one of the most important property which is used everywhere, even in advanced maths, is the linearity of expectation. This property is known as linearity of expectation. Linearity of expectation. Usually in the exam you won't get many questions on this. It's very rare. Even if it comes, it is termed as a hard question, but this is very useful in all kind of mathematics. And then we have the variance. Variance is the expected value of how far I am from the mean, right? So, and I find the distance by squaring it. So this is just denotes how far, what is the expected value of the distance of the random variable from its mean, right? And it has a very simple form. It is expected value of x square times the square of the expected value. So you need to remember this formula, otherwise it is very hard to compute sometimes. So if you remember this formula, you can compute it much faster. In examination also, you don't need to prove anything, you need to compute things. That's why it's better, right? And these are some formulas. I think this should be, you guys must be comfortable with this. Then, because here, as you can see, linearity of expectation, I don't need independence. So I can break down the summation even though the random variables were not independent. But if they're independent, given the product can be broken down. So expected value of x times y is just expected value of x times expected value of y. And for variance, that linearity of expectation doesn't hold anymore. You need independence to break down the summation, right? Any doubts till now?
No,
Yes, Rishabh.
no, I don't have a doubt. That's
Okay, yes. And we just using this, we define how two random variables are dependent on each other using the framework of covariance. So covariance of two random variables is just defined as expected value of the product times, sorry, not times, minus the expected value of individual random variables, right? So that's how you define, you get this formula after the definition. So definition is something which I've written top of it, but for the examination point of view, if you remember this formula, that is sufficient, right? And if the two random variables are independent, then you will see that covariance becomes zero. Why? By this formula, right? So by this formula, expected value of x times y just becomes expected value of x times expected value of y. And using this covariance, you define covariance coefficient as covariance of xy divided by standard deviation of x times standard deviation of y. That's all. So that was the thing about covariance, variance, and expectation. And now one of the another most important topic, you will for sure get a question on this, for sure. There is no doubt in that. Markov inequality and Chebyshev inequality. So people usually forget that Markov inequality you can only use when the random variable takes non-negative values. So it takes value like 0, 1, 2 till infinity, positive side infinity, right? The probability that x takes some value greater than equal to c is less than equal to the mean of the mean of that random variable divided by c. And Chebyshev inequality just states that how far are you from the mean, right? So this mod symbol denotes how far are you from the mean. So if you're k units far from the mean, then the probability of that being happening is bounded by the variance by that distance, which is k, right? So these two random, not random variables, these two inequalities are very important. So I will mark them also. So you can expect at least one question on each of these inequalities. So it's better to solve at least 1-2 questions on these, right? So let me just overview. So we talked about basic of probability, then random variables, and some terminologies like conditional independence and marginal. And then we analyzed RVs using expectation, variance, covariance, and we talked about these very important inequalities. Then we saw the continuous setting in very basic sense, right? And also people were asking like, will you get the formula sheet? And you will get this. I have copy pasted from exactly what you will see on the examination. So you will have this distribution. I have not talked about distribution because you will anyways get it, so it's fine if you just have the idea. You don't need to remember these kind of things, right? So you will get this formula sheet in your exams. I pasted this in the notes. When I will share it, you will find it, right? So first is the set of discrete random variables, then I have continuous random variables, right? So any doubts? I will take doubts for 4 minutes, 1-2 minutes or 4 minutes. Then I will start with the questions. Any doubt in the concept is also fine. I can discuss it in slightly more detail.
Hello.
Hello, yes.
Please, can you explain only about that inequality marking those and only that concept? Can you explain it again?
So I wanted to know. So there is proof, or you just want some intuition?
Hello.
Yes. So I wanted to ask you. You want like some kind of intuition about it?
Yeah, is introduction or some explanation because only those two inequalities, though the other concepts are a bit common concepts, but only these things
Yes.
are
Yes.
new to me.
Yes, that's a good thing that you've asked because you will for sure get a question in this. So it's better to just
Okay.
clarify, right?
Thank you.
So yes, thank you. So probability. So you have to first have a non-negative random variable, right? So if you have a non-negative random variable, then you can talk about Markov inequality. So probability that the random variable takes a value greater than equal to c. So here c is some value, right? This c is some value greater than 0, strictly greater than 0, is bounded by the expected value of x. So this is actually expected value of x by that same thing which is bounded. So there is a whole proof. I'm just explaining the symbols and notations. That's all, right? And Chebyshev is defined for all kind of discrete, all kind of random variables, not just discrete. You will see the continuous setting later. So probability that my x is how far from the mean. So this mu x is mean, right? So I will just draw a figure also, that will make more sense. So if suppose this is the mean mu x, so I need to find what is the probability that my random variable takes the value beyond this range. So that range is mu x plus minus k, right? So probability that my random variable takes the values beyond this range is bounded by the variance divided by k square, right? Does it make sense?
Yes.
Yes. So we will do a question also, so it would become more clear.
Okay. Thank you.
Okay, so let me start with the questions. Yes. So this is the first question. This is related to random variables in a discrete setting. So you have joint distribution, right? So let me write it also. This is joint distribution. So given this joint distribution, you have to find the marginal distribution of x. So I will just write the formula. Let me put A and B option, not option, the subparts. So joint distribution is given. So you want to find the marginal distribution of x at suppose point T. It's given by what formula? I'll just write it. Fxy T comma y, where this small y range overs the possible values of y, the random variable y. So what is this? This is just f xy t comma 0 plus fxy t comma 1 plus fxy t comma 2. Why? Because in the question is given xy takes the value 0, 1 and 2, right? So what is this? This is just x plus 0 by 36, x plus 3 by 36, x plus 6 by 36. You will get 3x plus 9 by 36, which is how much? X plus 3 by 12. Does it make sense? Right? So that's how you find the marginal distribution of x. You just sum over the other variables range. So if you guys are still not comfortable with solving these kind of question, I would suggest you to start doing, because I think there are not many days left, right? So these kind of questions will surely come. So I have picked like one of the like most popular questions. So what kind of topics which come most probably, right? So marginal distribution, conditional distribution comes every year. So every term, not every year, every term. So now I have to find the conditional distribution of y given x. So f of y x is equal to small x is what? I will write the formula, then I will substitute the values. So it is just probability y takes the value, one second, at a given value t, let me write it, at a given value t, it's just probability y is equal to the small t given that capital X is equal to small x. And this I know the formula. It's again the similar formula which we have seen. Probability y is equal to t and x is equal to x divided by probability x is equal to x. And this is what? This we have already calculated in the A part. This is the marginal distribution. So you will get fxy x comma y, and here y is just t. So I would write that t divided by f marginal distribution of x. And this is what? X plus 3t by 36, x plus 3 by 12, and this is just x plus 3t 3x by plus 9. Correct? Is it clear? I'm doing it in a very detailed fashion because so that you guys can understand. In the examination you can skip these kind of extra calculations, you can directly write this, right? So that's all. Is it clear, this question? Hmm? So let me move forward. I have picked a different variety of question now. So instead of
Can you show that slide? Okay, okay, fine.
fine. Yes. So in this question, we had a formula to get the joint distribution, but now I am given a joint distribution in form of a table.
Excuse me.
Yes.
Sorry. Can you just show me the previous slide? I'll take a screenshot. Please.
Sure, sure.
Thank you.
No issues. Yes. So now I am given a table along with the marginal distribution. So this is the marginal distribution of y here, and this is the marginal distribution of x at the bottom. So we need to check which of the following options are correct. So let me name this as A, B, C, and D. So let's check the probability that x is equal to y. So what are the possible cases? So x takes the value 0, 1, and 2, right? 0, 1, and 2, and y takes the value 0 and 1. So this is just the probability that x is equal to y is equal to 0 plus x is equal to y is equal to 1, which is how much? You just need to find fxy at 0 comma 0 plus fxy at 1 comma 1. And this is how much? This is 1/4 plus 1/8, which is, I guess, not 3 by 4, 3 by 8, right? And please check the calculations also. Sometimes I make a lot of mistakes, right? So A option is correct. Now let's do the B part. It says find the probability that x is equal to 2 and y is equal to 1. So where is it? This is, so I will go to this, x is equal to 2 and y is equal to 1. Is it 1 by 8? Sorry, is it 1 by 6? No, it is 1 by 8. So this option is wrong. Now let's do the C part. Probability x is less than equal to 2 and y is equal to 0. So what is this? This is just fxy 0 comma 0 plus fxy 1 comma 0 plus fxy 2 comma 0, which is exactly equal to marginal distribution of y at 0. Correct? Can you see that? So I will just mark it here. So this is just this, right? And this will give you 7 by 12. So this option is correct. If you can't follow at some point, just bug me in between. I will try to explain it again. Right? So now let's see the D option. It asks you, it asks you to find the same thing which we have already calculated. It is 7 by 12. So this is the wrong option. Is it clear? Right? So let me move forward. Yes, now this is a question on functions of random variable. So it's functions on random variables. So you're given x1 represent the number obtained in the first throw of throwing a dice. So we are throwing dice twice. A fair die is thrown 2 times independently, and x1 denotes the first instance and x2 denotes the number in the second instance, and I find the maximum. So this is the first question, and this is the second question. First question asks me to find the CDF. CDF is the cumulative density function, right? So let me proceed with this. Or let me not draw the table, will take a lot of time. So probability that x takes the value less than equal to k is what? It just says probability that maximum of x1 comma x2 is equal to k, which is equal to probability x1 is less than equal to k and x2 is less than equal to k. Is it correct? The statement which I've written, is it correct or wrong? It's not correct, because they should, at least one of them should pick the value k, right? So this would be just probability x1 is less than equal to k and x2 is equal to k plus probability x2 is less than equal to k and x1 is equal to k minus when both of them are equal to k, because this event is counted twice. So x1 is equal to k and x2 is equal to k. So this will just give me, and they're independent, so I can break down into separate pieces. We'll get k by 6 times 1 by 6 plus k 1 by sorry k by 6 times 1 by 6 minus 1 by 6 whole square. So I will just get 2k minus 1. That would be the CDF. Is it clear? Right, so let me move on to the next part. This is the first. Okay, let me see, is it satisfying the property of CDF? So at k is equal to 6, this should be equal to 1. Is it equal to 1? It's not even equal to 1. Okay, okay, but it's fine. Let me see the next part. So it's asking me probability x is equal to 4. So what is this? What should be the answer?
7 by 36.
Yes. So 2 times 7, sorry, 4 by 36, which is 7 by 36. So by the way, in this first part, I have not found the CDF. What I have found, this is PMF, right? So this is PMF. That's why the when you put k is equal to 6, you're not getting 1. So in order to find the CDF, so CDF will be given by fx at k is just probability. Sorry, here it should be equal to. That's why I was thinking where I made the mistake. So the first part I found the PMF, not the CDF. So for CDF, I need to find probability x is less than equal to k, which is just summation of 2k minus 1 by 36. Let me put t here as the dummy variable, and t is less than equal to k from 1 to k. So I will get 2 by 36 summation of t is from 1 to k minus 1 by 36 times k, because I'm summing k times. So what is this? This is 2 by 36 t times t plus 1 by 2 k by 36. I will get this should be k, not t. I will get k square by 36, right? So this is the CDF. Now if you put k is equal to 6, you will get 1, because CDF at the last, as you tend to the highest value, you will get 1. So this is the CDF. Yes, Rishabh.
Hello.
Yes, can you please repeat for PMF in Hindi?
CDF.
Sorry, PMF.
PMF is just
Yes.
the probability that you attain some value. So here I've just calculated the probability that x is equal to k, which implies the maximum on x1 and x2 is k. So I've divided this into two sub events, right? So probability that x1 is less than k and x2 is k, and similarly I've divided into some events, and then I've calculated the probability. Yes, Yogesh.
So while finding maximum and minimum, the answer will be in PMF format, right?
Could you repeat? I couldn't catch up.
Wait a minute.
In the meantime, Rani Swapna.
Am I
Oh yes,
audible?
Yogesh. Yes, yes, you are audible.
So while finding minimum and maximum, the means it will be in the format of PMF, right?
Yes, you will first find the PMF, and then you can find the CDF by summing up the PMF. Yes, Rani Swapna,
Okay,
you
okay,
can
fine.
talk. Yes, thank you.
Hello. If you don't mind, can you explain only the CDF? This T and K, I'm getting confused. If you don't mind.
Right. Sure, 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 sure. So it is just telling. So I will just write the PDF at all the points. So at first point it would be 1 by 36. Then I will have 3 by 36, 5 by 36, 7 by 36, then 9 by 36, and then 11 by 36, right? So this is for k is equal to 1, 2, 3, 4, 5, 6. So what I have done is I have just summed up till k. So if my k was 3, I have just summed up this, right? So this is just the calculation. So if you try to break it down, you can see that. So I am summing up 2t minus 1 by 36 from 1 to k, right? So is there confusion with the calculation though, or with the idea?
Because you have changed the variable here t, and then again it changed to k. So that concept I'm not
Yeah,
getting.
yeah, yeah, right, right. So here the summation is over t, where t goes from 1 to k. That's why I'm not used the value k. That is the difference. Yes,
Oh,
summation. Yes,
thank you.
yes. So t is a indicator variable which goes from 1 to k. That's all. That's why I'm not repeating the variable. Otherwise, the notation will become wrong. That's all. Right. So now we'll come to analysis of RV. Again, we come to a most important topic, which is inequalities. Right. So let me read the question. A company has scheduled interviews for job applicants, and 40 people have confirmed their interview slots. Each applicant independently attend the interview with probability p is equal to 3 by 4. So right. So for each person, I have defined a random variable xi, and it is 1 if you attend the interview attended, and otherwise. So probability that xi takes the value 1 is 3 by 4, which is p for all I 1 to 40. So this is the notation from 1 to 40. Yes, any Rishabh, do you have any doubts?
Yes, I have a doubt in previous question actually.
Yes, yes, sure.
Yes, how do you write k by 6 in PMF? This
Actually,
probability is
actually, your voice
x.
is very mumbled. I can't hear anything. Can you just type?
One second.
Yeah, sure, sure. And Rani Swapna,
Can
do you
you
have any doubts?
hear me?
Yes, yes, yes.
My question is how you write k by 6 into 1 by 6.
K by 6 into, oh, sure, sure, sure. So this is what? So this is the probability that x1 is less than equal to k, and this is the probability x2 is exactly equal to k. That's all. Is it
Yes,
clear?
how you write probability of x less than equal to k?
Yeah, so it's just like it takes value 1, 2, 3, 4, 5, 6, right? So
Okay.
probability that it takes value less than equal to 3 is just what? 3 by 6, right? And similarly
Okay.
for 4, 5. That's all. Right? So I was doing this question. So here the probability that you will attend an interview is 3 by 4, and I have defined an indicator variable xi where I is for each person, right? So now x denotes the number of people who have attended the interview. So x is what? X is just the summation of xi. I is equal to 1 to 40. So x1 plus x2. So xi's are 1 if and only if you have attended the interview. That's why the summation will denote, sorry, the summation will denote that how many people have attended the interview. So now I have two questions here. So using Markov inequality, find an upper bound to the probability that p is, sorry, x is greater than equal to 35. So what is it? It is the mean of x divided by 35, right? So I need to find these quantities. Just give me a second, right? So what is x? Can you tell me what is the distribution of x? It is just binomial with n is equal to 40 and probability 3 by 4. And expectation of x is just n times p, which is 40 times 3 by 4. So if you guys are not comfortable with the distribution, I would suggest you to revise this, right? So this is 30. And what is variance of x? It is just n times p times 1 minus p, which will give you 40 times 3 by 4 times 1 by 4. Right, so what will you get? 3 by 4, 120 by 16, 30 by 15 by 2, right? So you'll get the expected value as 13 and variance as 15 by 2, right? So for the first question, I need to find the value, probability that x is greater than equal to 35. And this will come out to be 30 by 35, which is 6 by 7, right? So that's how you do it. For the second question, The question says, using Chebyshev inequality, find an upper bound to the probability that at least 35 people attended an interview. Do you know how to start with this question? Any idea? So this is what, so probability that x is greater than equal to 35 is less than equal to probability that this, right? Why? So my mean is 30 and here is 35 and here is 25, right? So probability that it takes the value around this point is greater than the probability that it takes the value just here, right? Right? So it's by the formula we have, not the formula, by the definition of probability, the probability of a superset is greater than the probability of a subset, right? So just through that, and this is what, this is bounded by variance of x by 5, which is how much? 15 by 2, sorry, this is square, by 1 by 25 square. Sorry, 1 by 25, not square. So I will just write 1 by 5 square. So what will you get? You will get 3 by 10. Correct? Does it make sense? So this quantity here, this event that you are like 5 units far from the mean, which is 30, is a superset of the is a bigger event than your x is being greater than 35. That's the only thing. So you need to think about this, how to do it. Any doubts?
Uh, I
Yes,
didn't
Yogesh.
understand that why you take that variance and that below that 5 square. Can you explain what which formula has been applied there?
Yes, yes, this is just a Chebyshev inequality. Let me go back once more. So this is the inequality. Is it clear?
Okay, okay, fine. Sigma square. Okay, variance.
Yeah,
I
sigma
got
square
it.
is the variance,
Mhm.
right? So let me move forward. Suppose x and y are independent random variables. Independent, you need to remember, it's important, with mean 10 and 20 and variance 2 and 4. I need to find variance x times y. How should I tackle this question? Any idea?
Calculate individual variance and then multiply them.
Yes, individual variance is already given, by the way. You don't need to calculate. And you can't separate it out because it's a product, right? Right, so here you are given a hint that if x and y are independent, then x square and y square are also independent. So where can you see x y? So if you remember this formula identity on real numbers, a plus b whole square is equal to a square plus b square plus 2ab, right? So I will just find first variance of x plus y whole square, just variance of x square plus variance of y square plus variance of 2xy, and this 2 will come out as 4. Correct? Sorry, it's not the comma, it's xy. And what to do after this? Any idea? Okay, so let me move forward. This is what? This is expected value of x power 4 I want to hear some ideas because this question is something which usually does not come. This is a very different kind of question. So do you know how to approach this? Okay, I'm not receiving any response. So let me not spill the broth. I will give you some time to think. So the hint is just this, what I've written here. A plus b whole square is equal to a square plus b square plus 2ab. And I've written some portion of the solution also. Right? So try to think. I'm not going to spill the broth. You have some time. The quiz is on Sunday, right? I will share the notes. I will share the solution in the notes, but try to do it before seeing the solution. Right? So let me see what else are there. Okay, now we want to talk about continuous setting. Let me see. Yes. So I'm given a PDF. This is PDF. Probability density function. So if you integrate this PDF, you will get the CDF. Right? So I have to find the value of C such that this PDF is valid. So one thing you need to remember, integration of PDF from infinity to minus infinity to infinity should give you 1. So the area under the curve should be 1. But here, because your probability just lies between 0 and 1, so you can directly find the integration between 0 and 1. So integration from 0 to 1, cx square minus 1 minus x dx, it should be 1. I will take out the c and I will integrate x square minus x cube dx, and I will equate it to 1. So I will get c times x cube by 3 minus x4 power 4 by 4, 0 to 1 should be 1, which implies c times 1 by 3 minus 1 by 4 should be 1, which implies c should be how much? 12. Correct? So for whenever you need to find these kind of things, you just need to check the integration should be equal to 1 and you will get the value of c. Let me do the second one. So to find the CDF, what you do? So CDF of capital X at small x is just integration from minus infinity to x of the PDF, which we have computed as 12 times x square times 1 minus x dx from minus infinity to x, because the probability is the probability becomes non-zero from the point 0. It starts to become non-zero after the point 0. That's why I can, instead of this minus infinity, can write 0 for all x greater than equal to 0. So fx x, oh, 1 second, there's some notational issue. I'm using the same variable multiple times, so fx at t is just this. So the CDF of this would be integration from 0 to t of 12x square minus 12x cube dx, which is just 12x cube by 3 minus x power 4 by 4 from 0 to t, which will give you 12 times t cube by 3 minus t power 4 by 4, which is 4t cube minus 3t power 4. Any doubts in this? I'm just doing integration. There is no too much of brain involved, right? Is it clear what kind of computation I've done? Yes. So let me move forward. So you're given two IIDs with this distribution. I don't know why I've kept this in continuous, but sorry for that. This should be in the discrete setting. Should be in discrete section. Sorry for that. So x and y are uniform distribution over sorry, x and y takes the value -1, 0 and 1 and has uniform distribution over it, and you define a random variable which is equal to the modulus value of their sum. The first question is find the probability mass function of z, and then there is some kind of conditional probability. So what are the possible values of z? Z can be 0, Z can be 1. Can Z be 2? Can Z be equal to 2?
No, it can't.
I guess no.
It can be, because X and Y, if they take the value 1, it can be, right? What about 3? It can never take the value 3, because mod X and mod Y are bounded by 1. So it will only take these values. So now I will write the values of X comma Y when it takes the value 0. So Z is equal to 0 takes the value when both are 0, and each of them cancel each other somehow, right? So either one is -1 and other one is 1, and Z is equal to 1 when at least one of them is 1, or at least one of them is -1. Exactly one of them is -1, sorry. I'm just writing the cases. For Z is equal to 2, both of them needs to be 1 1, and or both of them needs to be minus and minus 1, correct? So these are the possible cases. So in order to find the PMF, we just count the number of possible varieties. So there are 9 choices, and just divide by the possible number of outcomes you need to get that value. So here that is probability 3 by 9, because it has 3 possibilities to get 0, right? In 3 ways it can become 0, and it can become 1 in how many ways? 4 ways, and it can become 2 in 2 ways. So that's all. So now the second question is the first one. Probability that X is equal to 0 given Z is equal to 1 is what? Probability Z is equal to 1 and X is equal to 0 divided by probability Z is equal to 1. So let's see the case when Z was 1 and X was 0. So what are those cases? Z was 1 and X was 0. So this case and this case, correct? So there are two cases. So that has probability 2 by 9 divided by the probability that Z is equal to 1, which is how much? 4 by 9, and you will get half, which is 0.5. Is it clear? You just need to find all the possible choices. That's all. So let me move forward. I think this is the last question for today. After that, I will be taking doubts. Yes. So let me
Can you show that slide, please?
yeah, sure.
Okay, fine.
Yes,
You can
I'm
change.
here. So now I'm giving a probability density function of some continuous random variable like this. So one thing you should note, area under the curve should be 1. Area should be 1, right? And this will help you to find the relation between alpha and beta. So this is the first question. I've not written the question, sorry for that. So you have to find the relation between alpha and beta so that this becomes a probability density function, and this is the second question. So in order to tackle the first question, I need to find the area under the curve. First, area under the curve is equal to 1. So what is the area under the curve? So let me help you. So this is a basic geometry we have done in school level. So this is also, this is alpha comma beta by 2, and this point is minus alpha comma beta by 2. So area is what? 2 times the area of these triangles. Sorry. So area of the triangles are, area of the triangle, because there are two triangles of identical shape and area, I will just multiply by 2, right? So I will just calculate the area of one and multiply. So half times, what is the length of the base length is alpha and the height is beta by 2, and area of the rectangles at bottom, they are also identical, so they are 2, so I will just 2 alpha times beta by 2, and the summation comes out to be 2 will cancel, alpha beta by 2 plus alpha beta Yes. Somebody wants to ask a doubt. Okay. Yes, so you will get 3 alpha beta by 2 is equal to 1. So which option is correct? This one, right? That's the idea. You need to just find area under the curve and find the relation between alpha and beta. Just check with the calculation. My calculation usually are very wrong. So the calculation could be wrong, but the idea is correct. The idea is just need to find the area under the curve. We have to find probability that mod x takes the value less than equal to alpha by 2, less than equal to alpha by 2. How will you find? So let me just draw this again, the figure. And here was your minus alpha, and here is alpha. So I need to find the probability that it takes the value between alpha by 2, right? So I need to find this area. Can you guys see this? Mod x takes the value less than alpha by 2, just it will be done by this area. And area of this, I will just compute. What is this? This is 3 beta by 4, because this was beta and this was beta by 2. So area under the curve here is area of yellow region it's just 2 times the smaller triangles. So width of those triangle is alpha by 2, so half times alpha by 2 times their height, which is beta by 4, plus area of the rectangles, bottom rectangle, so there are 2, so I will just have alpha by 2 times beta by 2, which will give me, so 2 will cancel, alpha beta by 4 by 8 plus alpha beta by 2, 5 alpha beta by 8. And because this option is correct, alpha beta is equal to 2 by 3, I can just substitute. I will get 5 by 8 times 2 by 3, which will give me 5 by 12. Correct? Does this make sense? So in the calculation could be wrong, but you should get the idea that I need to find the area under the curve such that mod x is less than alpha by 2. So this area will cover that. Yes. Any doubts?
Please, can you explain the second part, please?
Yes, sure. So here the main issue is you need to check which area is covered by this event. So the event says modulus value of x is less than alpha by 2. So in this figure also, can you see? So alpha by 2 somewhere lies here, and sorry, minus alpha by 2, and here is alpha by 2. So you need to find the area between these two regions, right? Between these two lines. That will capture the event that my x absolute value of mod x, sorry, absolute value of x is less than alpha by 2.
Sorry, how did you get that 3 beta by 4 or something like that? Yeah. So
3
can
beta
you?
by 4?
Yeah.
Where is 3 beta by, oh, this 3 beta by 4. Oh, okay, sure. Okay, got your point. Yes. Okay. That's a good question. In the sense, I'm using a geometry result. So let me just write it here. See, if I have a triangle like this and I divide it perfectly in the middle on one side, so this will make these two sides equal. So if originally this side was equal, so I divided in a perfect way, these two sides were equal, and if I go parallel to the bottom edge, it will also divide the other side equally. I don't remember the name of this theorem. So there is a theorem like this, right? So I'm dividing, suppose this is the line AB, and see, if I'm dividing line AB in middle parallel to the line BC, then the side AC is also divided equally. So here also, because this line, let me call it PQ, PQ divides the PQ goes parallel to this line, right? RS. So PQ goes parallel to the line RS and divides it perfectly in middle, right? So that's why it will divide this portion equally. This portion equally. So even if you don't remember the what you call the theorem or something, you can see by intuition. You can start drawing itself. You will see it will divide exactly in between beta and beta by 2. That's why I look at 3 beta by 4. But these questions are very rare. I remember this came when I was doing stats too, but these kind of questions usually don't come. I've just picked it up because I found it slightly interesting. But this is a
Thank
very
you.
rare instance. Yes.
Thank you.
Any other doubts? So that was all which I wanted to solve. I will ask you to solve this question, by the way. Please try it. Yes.
Can you
So I will just
solve it here itself? Because I guess if we didn't receive notes, like
okay. By the way, I also wanted to know, where did you guys receive the link for this meet?
By WhatsApp.
Oh, it's in the doubt corner.
No, we there is a WhatsApp called Direct BS Degree or something. In that WhatsApp, unknown IITs or something. From that, we got this. I got the link.
Okay, okay, sure, sure. So I will just ask operational team where it was shared, so that I can share the notes. Otherwise, it's you guys can't do it. Yes. Let me just go over the quiz one thing also. So these are the short notes which you should revise before the quiz. That's why. So any doubts in this theory portions? And I've attached the formula sheet as well. No doubts as of now. So yeah, this is, by the way, this is my email and LinkedIn. So LinkedIn I most probably don't check. So but you can email me anytime for any doubts or anything through the chat. Right. So that was all for my side today.
uh,
Thank you everyone.
please can you
Yes, Yogesh.
teach that means question, solve that question that you have left
Oh, okay,
for
okay,
us to
yeah. Sorry,
solve.
sorry, sorry, sorry. Yeah, I missed in between. Yes, correct, correct, correct. Variance of x comma y.
Mm.
Yes. So let me take up this. So I'm given x and y are independent random variables with mean 10 and 20 and variance. Yes. So let me write it separately. Right? It is just this. 1 second. Check last slide. Let me do it at the last slide. Space is very less. Yes. So variance of xy is just given by the formula expected value of xy minus mean of xy whole square.
But how did this came? Like,
This
can you
formula?
show that?
Okay, okay.
No, not
Uh,
formula. Like,
Then,
how did you evaluate it?
yeah, just 1 second. So, 1 second, I just wrote this formula very wrongly. The square is outside and then there is a bracket. So I will get x square y square plus expected value of xy whole square minus 2 times xy, expected value of xy, right? So this formula is correct. Then you will get expected value of x square y square plus expected value of xy whole square minus 2 times expected value of x, expected value of y, expected value of xy. And now you have to use the hint. Hint is that if x and y are independent, then x square and y square are also independent. There is a very general theorem also, but here we can use the doubt. So this will break down into expected value of x square, expected value of y square, and expected value of some constant thing is just that constant. So you'll get expected value of xy. Yes, this whole square minus 2 times expected value of x, expected value of y, and again this will give you a constant xy, expected value of xy. Right, so now you just need to compute this. So how will I compute expected value of x square? It is just variance of x plus expected value of x whole square, and expected value of y square is what? Variance of y plus expected value of y square. Does this make sense? Yes,
Uh,
somebody raised their hand.
I didn't get it. Can you explain it in Hindi, like this last question?
In Hindi.
Please.
हाँ, so
Because
I like मेरे को पता नहीं वेरिएंस और एक्सपेक्टेशन को हिंदी में क्या बोलते हैं, बट variance of xy, I'm just okay, again I'm converting to English, I'm really sorry. So variance of xy को मैं कैसे लिख सकता हूँ? Expected value of the difference between xy and its variance whole square, right? That is clear, right? This formula is clear. After
yes,
that मैंने बस
yes.
अंदर वाली चीज को expand किया है using the identity a plus b whole square. Sorry, here it's a minus sign, so minus 2ab. Let's say I've just used this identity. उसके बाद I have used linearity of expectation. So this question uses lot of things. Question uses lot of things. Linearity of expectation, right? So after that, जब मैं linearity of expectation लगाऊंगा, उसके बाद expected value of x square y square would come out as expected value of x square and expected value of y square. So for this thing, you need to use the hint that x square and y square are also independent, and then everything follows. So you will calculate expected value of x square using this formula, expected value of y square using this, and these terms are already given to you, given in question. ये question में दिया हुआ है, given in question. That's why I was asking you to write it first by yourself. Just why I gave you the hint, because there are a lot of intricacies in this. Yes, Rani Swapna. Any doubt?
Um, Sorry, even I didn't understand. It means, or else, can you put the numericals and then can you work it out and show? Because with this
Okay, the
variable,
value with the
yeah,
value.
yeah, with this little confusing with the variables.
Sure. I can do that. Let me copy it there. There I have some space. Let me see if the calculations are right here. Yes, seems
So I
right.
just want to know what is the final formula after derivation. What formula are we derived with the variance of x y?
Okay. Let me tell you, you don't need to remember this formula. This formula is not at all necessary. So this will ये आएगा आपका expected value of x square, expected value of y square plus expected value of x, expected value of y whole square. Right, so you will get this, and this will be equal to variance of x plus expected value of x whole square, variance of y, expected value of y whole square. So you will get this formula. Is it fine now? And these values are given in the question, right? Now you can try, and please check the calculation also. As I already told, I make a lot of mistake in calculation, so please check the calculation, but the idea remains the same.
Okay, thank you.
Thank you. Yes, so that was all for today. I can take up doubts if you have any doubts. Karishma, that is not part of week 1 to 4. That will come in 11th and 12th week. I have
Okay,
not.
so no doubts.
Yeah.
Hello. If you have
Thank
any
you.
doubt, oh, okay. So thank you all for joining this revision session. Hope it helped clearing your doubts. And a special thanks to Vardhan for guiding us through the concepts and making it easier. Thank you all. See you in the next session.
So this session contained all 4 weeks, right?